and welcome back to my channel. So today we are going to talk about application of integrals in mathematics. So there are many applications of integrals everywhere. So we can start with something basic to get to know the area of a circle using integrals. So we know that if we have been given a circle with the radius a, so the equation of the circle is given as x squared plus y squared equals a squared, right? So we know that definite integral is given as the area under the curve f of x, and here if I draw a circle, so here I have a circle. So the equation of this circle is, if I write in terms of x, so y will be a square minus x square. So now we have got the equation of the circle. And in definite integrals we know that definite integral is defined as the area under the curve. So that means we can find the area of the circle using definite integrals, right? So if we find the area of this part and multiply it with 4, we'll get the area of the whole circle. Now how do we do that? How do we find the area of this quadrant, this part? Now we can name, let's say this is O and this is B and this is C. So the equation of this circle, this is the curve. So here the equation of the curve is given as under root a square minus x square, right? And x is 0 here and x is a here, right? So we have x, the area is bounded by x equals 0 this line and x equals a, and the value of the function, this curve, and also the x-axis. So what I can simply do is I can put limits and try to integrate it using definite integrals. So I have the function of x and integrated with respect to x, and between 2 points x equals 0 and x equals a, and the function is given as under root a square minus x square dx. So it's that simple. Now this is only the area of the quadrant of the circle, 1/4 of the circle. So if I multiply it with 4, I'll get the area of the whole circle. Now this comes out to be 4 times x by 2 under root a square minus x square plus a square by 2 times sine inverse x by a. And if I apply the limits, 0, the lower limit will be 0 and upper limit will be a. Now if you want to know how I got the integral as this one, I'll have to dig a little deeper, and if you want to know how I got the integration of under root a square minus x square as this one, you can write in the comments below and I'll show you in the next video how do we do that. But for now, it is actually a standard integral function, so we have to learn this. The derivative part, if you want me to know, I'll teach you. So here I've got 4 times this one, and I just have to apply the limits. So it comes out to be 4 times a square by 2 times pi by 2. It comes out to be pi a square. So we know that the area of the circle is given as pi r square, and in this case a is the radius. So now we have got the real actual area of the circle using integration. So now we understood how to use integration, the application of integration. Now let's try to solve another example. Here we have to find, we have been given a circle. Let's say this is the circle, and I'll draw the axis, and this is the y-axis, and this is the x-axis, and also I have got a line which is a straight line. Yeah, so this is y equals x. So this line is y equals x, and the equation of this circle, as we know, is a square minus x square, right? So here the question is, we need to find the area of this part, only this part. How do we do that? What we can do is, first we can just draw a perpendicular line here. We can find the area of this triangle. Let me name this O, B and M and A. So first I'll find the area of this triangle, and then I'll find the area of this one. So what I can do is, the radius is given as the equation of the circle is given as 32. X square plus y square equals 32. That means under root 32 is the radius of the circle. So the radius comes out to be 4 under root 2. Now, as I said, we can use definite integral. So first I can find the area of the triangle, that is 0 x's from 0 to m, and the function is the area under the curve is, this is the function y equals x, and the area under the curve is this one. So that's why, as we have y equals x, so the function of x is only x, and I'll integrate with respect to x. So this gives me the area of the triangle, and then plus the remaining area will be m, from m to the radius of the circle, that is 4 under root 2, and the function is given as under root 4 under root 2 square minus x square, right? This is the function. So first let's solve this part, and then we'll come back here and do this part. So here this is easy. The integration of x is given as x squared by 2, and just applying limit 0 m. So before we begin, we need to find the point m. We don't know what is the value of m, and to do that it's simple. So we know that y equals x here, and that means it is intersecting this function here. That means y equals x in this function as well. So let me show you. We have x squared plus y squared equals 32. So when y is equal to x, I can simply write x squared plus x squared equals 32, and this comes out, x comes out to be 4, and y comes out to be 4 as well. So at this point we have 4, 4. So therefore m is equal to 4. M equals 4. Therefore this limit will change to x squared by 2, 0, and upper limit will be 4. The area will come out to be 8. So this is the area of the triangle. Okay, so now we have to find the area of the remaining part. So that is given as 4, x equals 4, from 4 to 4 under root 2, and the function is given as 32 minus x squared. So again, in the previous question, it is same as the previous question. So the equation, the integral will come out to be 1 by 2 x under root 32 minus x square plus 1 by 2 times 32 times sine inverse x by 4 under root 2, and then we have to simply apply the limits here, upper and lower limits. So this comes out to be, so this part comes out to be 4 pi minus 8, right? But we have the area of the triangle plus this, so we have to add those two, and that gives us the area of the required part. So let me write it again. We had 0 to 4 x dx, then plus 4 to 4 under root 2, and 32 minus x square dx. So this came out to be 8, and this came out to be 4 pi minus 8. We just need to add those, and the area of the required part is 4 pi. So this is how you use definite integrals to find area of the required any geometric shape. So thank you for watching, and if you want me to dive deep into the standard integrals of those types, let me know in the comments below. Thank you for watching.